Good afternoon all. What are you up to today? Well, what I'm doing in my hunt for the ultimate battery charger is taking a look at this. It's the Adeaska SQ4 Plus intelligent LCD charger. And at first glance, it looks pretty good. Up to 2 amps charging current per slot. There are 4 slots. You can select half an amp, 1 amp or 2 amps charge current. It does lithium ion, lithium iron phosphate, nickel metal hydride, and nickel cadmium. LCD screen. It's got a USB output. That's a bit of a gimmick. Now the input says 12 volts, 3 amps. We're going to have to see if it can take a bit more than 12 volts. What have we got today? We've got 13.6. The display looks pretty good. Let's zoom in on that. There's only a lot of information here. We've got milliamp hours accumulated, milliohms, so internal resistance, voltage of the cell on a little bar graph thing there, time, current, half an amp, 1 amp, 2 amps, and the chemistry. And you've got that repeated 4 times. That's a lot of segments. Now, this battery charger has been very kindly supplied by Banggood.com, and there will be a link below in the description where you can go and look at this on Banggood's website. Thank you very much to Banggood for sending it in. Right, what have we got in the box? We've got a European mains lead. Well, I suppose we are in Europe still, just about. And we've got a switch mode power supply, 12 volts, 5 amps. And that's got a clover leaf figure of 8 type. No, not clover leaf, figure of 8, the 2-pin one. Connector so that I can, well, I don't need that lead anyway. And here's the battery charger. It's the Adeaska SQ4 Plus Stinger. Right, let's peel that protective coating off the screen. Now I'm not going to use that power supply. I'm going to use my voltage coming from my lead acid batteries outside. Power from solar. Right, let's power it up. That says center positive, so in goes my 13.6 volts. And yes, masses and masses of segments on this very large backlit display. Right, let's start by testing this reverse battery polarity monitor and protection. Let's see what happens. Reverse polarity. Oh, it just flashes everything. Let's do another one. Reverse polarity. Yeah, flashes everything on and off, saying that's no good. Now let's try these two the right way around. These are nickel metal hydride. They're Duracells. And see what we get. Okay, we've got some data. I'm going to get a bit closer. Well, as we saw before, we've got milliamp hours accumulated. We get a milliohms reading, but it does look like it only does that once, and that doesn't appear to be updated. So I think it just does that in the initial stage. We've got voltage indicators here. These two batteries are virtually fully charged. You can see that it's charging them at half an amp. Now I think we can change that. No. It also indicates that it sees these as nickel metal hydrides, and they've both been running for approximately 1 minute. Now, of course, in addition to nickel metal hydride, what I also want is a charger that can do lithium. So here's a generic lithium cell, and here's a protected cell. You can see it's protected because it's got the strip running down to the circuit on the bottom. Let's put that in. Yes, that takes up the full slot size. So the advantage with this battery charger is it will do the extra dimension of a protected cell. Whoops, there's a non-protected cell, and let's take a closer look at the display. Right, well, it's detected that they're both lithium ion. It started them both at half an amp. Can we change that? Yes, I can put that up to 1 amp. Now the central slots only go up to 1 amp because this is a heat issue. The outer 2 slots actually go up to 2 amps. You've got 3 different current selections. We've got 4.19 volts on the blue, so that one is pretty much up to voltage. And the pink one is coming up. Now, interestingly, it said that we've got 512 milliohms for that blue one, which is non-protected. I would have thought the protected one would have shown a higher internal resistance because, of course, it's got the electronics, which will have a MOSFET, so you'll have the internal resistance of the MOSFET added into that, but that one's showing quite a bit lower. Right, let's try a couple more lithiums. I've got a through night cell here, that's protected. I've also got a lumen top. This one's a high capacity, 3400. That's also a protected cell, so let's put that one in the left slot. See if we can put 2 amps into these two. Just check that that's the right way around. If it were the wrong way around, it would tell me, I guess. 147 milliohms for the lumen top, 153 for the through night. The battery of the through night is virtually fully charged. This one isn't. Let's see if we can wind the current up. 1 amp, 2 amps, and this one 1 amp, 2 amps. So that's going to be drawing more energy from my power connector there. Now I really like this display. You've got at a glance voltage here as a pictogram sort of thing, also in numbers, and you can see every parameter of every cell all at the same time. I do like the fact, oh that's just gone dim, I do like the fact that this thing is incredibly easy to use. These buttons just do current, they don't do anything else. So it's really simple, you're not going to forget how to use it. Okay, it doesn't do the sort of analysis and multiple cycle modes and doesn't do discharging, but as a sort of everyday go-to charger, chuck a few cells in it, modify the current if you want to do it a bit faster, and it just gets on with the job. Right, let's see how it copes with a quick change of cells. We'll whip out these two middle cells and I'll bung in a couple of inner loops. I've no idea what state of charge these are. Let's see if it can just handle different things being thrown at it. Yep, so it's detected that that's nickel metal hydride, that's nickel metal hydride. They're both about 1.25 volts. And away it goes, 0.5 amp. Can I change that current? No, it seems that nickel metal hydride can only be done at 0.5 amp. Here's the interesting thing. Look, if you take the power out, it stays on and it says USB. It's actually making a whining noise now. And what it's doing is it's using the lithium cell to provide power to the USB socket on the back. So it can actually work as a power bank. It's a bit of a gimmick and it doesn't work with nickel metal hydrides. But yeah, if you put lithiums in here, it's got a power bank mode. So, okay, the maximum 0.5 amp charging for the nickel metal hydrides is a bit of a limitation, but I generally use the Technoline BL700, I think it is, charger, which only charges if you don't press the buttons at 200 milliamps. So 500 milliamps is a step up from that. You can have 0.5 amp, 1 amp or 2 amps if you put them in the outer slots on the lithiums. I think this could become my go-to everyday use charger. Shall we take a look inside? I think we should. We seem to have little stick-on feet which come off really very easily, and oh yeah, it looks like we've got 8 screws around the outside of this thing. So let's get all these off, and oh no, there isn't one there, so 7. Yes, this is interesting. This doesn't look like it's going to want to come out unless I release some of these springs. Perhaps I'll have to do that. Right, well, we have a liquid crystal display board. I'm probably not going to take that out. It's held in with 4 screws. Big Holtec chip there, doing all of the display. Not many wires running from the main board to the display board. Mostly serial data there, I suspect. We've got a microcontroller here. It's an STM32F. And we've got 4 fairly independent looking channels, each with its own inductor, big resistor. What's this thing here? Is that a MOSFET? Could be a MOSFET. It seems that lots of the pins are actually tied together. And some diodes and some transistors and some bits and pieces. There's another little power supply section here. The little inductor 3R3. Probably a controller chip there. And a few diodes and bits and pieces next to the 12 volt input and the 5 volt USB output. And we got 4 sort of metal slider things here dangling in the breeze. They're quite nicely greased. I don't really want to interfere with that too much. I don't really want to take the display out because I don't want to get dirt in between the display and the front plastic. So yeah, STM32 microcontroller, actually quite a small amount of sort of high power circuitry in there. Quite impressive, really. So just refit these springs. That doesn't look too difficult to do. He says failing to get that on there. get on there. Yeah, that's got to be held in by the mouldings on this back panel there. So let's get the back on. Yeah, so if this charges reliably, terminates reliably, I suppose is the main thing, then I've got a feeling that this is the one I'm going to use. I can throw batteries at it, have them charge at 0.5 amp, even if I can't be bothered to press the current change button, or more than that if I can. So just check that I've got these sliders back in the right place. Actually, I can put a cell in there, can't I, without even connecting it up, and it should power up from the energy in the cell, and say USB. If I plug in my 12 volts, it should then also start charging. Away it goes. So yeah, I like this thing. 12 volt input, works perfectly happily on 13.5 volt, dual chemistry, so it does the nickel metal hydrides and the lithiums. Masses of information on the display, and a nice little power bank feature to boot. And after a couple of minutes, the backlights switch off, but you can still see the display, which is pretty good. Press any button and the backlights turn on again. And there we are. When the cells are full, it flashes full on the display. So these two cells are now full. Yeah, I think this thing's going to be useful. Cheerio.